Recently I did a video about this. This is an RGB to HDMI adapter, and I'd managed to blow up the 1.2 volt power rail by putting more than 5.5 volts into it. So I ended up replacing that rail with a buck circuit, an external buck circuit, and just connected it to the voltage in and the voltage onto the 1.2 volt rail. The reason I replaced the chip here with this external regulator is because at the time I didn't know what the chip was that was there before, because it was completely burnt out. Subsequently, I was having a look through some photos on my iPad, and I came across some pictures I'd taken of the board, and using those pictures I was able to see the writing on the chip and actually work out what it was. And it was one of these. It was a tech code TD6810B. Now when I looked for these on AliExpress, there's several different types available. There's some kind of fixed output ones at kind of 1.2, 1.5, 1.8, 3.3, you know, the usual. And there's also this adjustable one. Now looking at the circuitry around the old regulator, it looks like it was the adjustable one where, you know, two resistors form a divider in order to program the voltage of the chip. So I ordered a pack of 10 of them from AliExpress for some silly amount of money. And by silly I mean ridiculously cheap. And the video today is going to be a video on actually replacing that chip. Now I just want to give you an idea of how small this chip is. So this is it here. So we're going to be doing this repair under a microscope. But first of all I need to remove the old regulator, which I'm going to do now. Shouldn't take too long. And then I need to clean up the pads that I've been attaching wires to. I also need to put the coil that I took out of this position back in again, and I can't actually find that coil, but I have found one that is identical, so I'm going to fit that. So the pads we're really interested in are these ones down here, which I'm going to do under a microscope, but also this bigger one here for the coil. Just want to give that a bit of a clean up. That will do. Now we need to switch to the microscope. Okay, so let's put a little bit of flux on there. And then we'll just, there we go. And we'll just use some solder wick to clean those pads before tinning one of them and putting the new chip back on. Apologies for that going out of shot. It's a very tight working distance on this microscope. It's really easy to just move stuff out of shot, unfortunately. But that's as clean as I need it. And what I'm going to do is put a bit of solder on one of those pads and then manually solder the chip on. We've already got flux on there that should be okay to use. Let's put a bit of solder on one of these, probably that one there. I'm actually going to put a little bit more flux on as well. Could really do with a nozzle on this flux really, that would make my life a bit easier. Just drop that on there. Flow the flux a little bit just to get it a bit clearer. There we go. Just get that on there. That's one corner done. Now we can do the others. This is why we have solder wick. So what we've done is just bridge two of the pins just down the bottom there. I'm going to put a little bit of solder wick on it and just get that solder out, like so. There we go. And that is all fine. So the only thing really left to do is put the new coil on. So I'm going to put a little bit of solder on that. Drop the coil on top of it. Now that seems to be a very good replacement for the one that was on there. In fact, what I think I'm going to end up doing is I'm going to end up using hot air to do that, because I don't think I can get under it easily. So I'm going to just tin these pads. I'm going to use hot air to reflow that coil onto the board. And we should see the coil move into place once the solder melts. There's a lot of copper around there, so it's going to take a little bit of heat to do it, I think. You don't want to burn anything else out doing this. Okay, that solder's melted. I just didn't see it move. Now I'm going to give that chip just a bit of a clean up, just to get the excess flux off of it. That'll look a lot nicer once that's done. Those connections look good. You can do this without a microscope. You can just do it with a pair of magnifiers. But it's much easier with a microscope. All that remains now then is to plug it in and see if it works. So I've plugged it in and nothing's blown up, so now I'm just going to check the output voltage and just make sure that's in the right kind of range. Which it is. And we can see that it's working absolutely fine, no weird aberrations or anything like that on that screen. I've actually plugged this into an Amstrad CPC6128, which is what I use this adapter for. Testing and repairing and the like, and that works absolutely fine. If you've enjoyed watching me repair something twice, but in a different way, please like and subscribe. Thank you very much for watching this video. Goodbye.